In this lesson, we're going to discuss inverse functions, and this takes us back to Chapter 2, where we actually learned what an inverse relationship was. And if you recall, an inverse relationship is simply when we switched the x's and the y's. So basically, our input values and our output values, or our domain and our range, were basically switched around, and you can see visually that's depicted right here. So if we have an original relationship in blue, and then we just flip the x's and y's and change that relationship, we've inversed the relationship. Now, as we've talked about inverse relationships in the past, we know that they basically kind of cancel each other out, or they offset each other. Now, that is more about when we're talking about inverse functions. So we'll talk about inverse relationships and inverse functions in this specific unit, in this specific lesson, but we need to figure out a way to identify a function's inverse. So, we've talked about addition and subtraction being inverses of each other. Those are inverse operations. So we're going to talk about specifically the functions themselves, if they're inverses or not. Now, in general, if you were to take this set of numbers, or ordered pairs, and graph them, we would have this relationship here that you can see very clearly creates a linear pattern. And of course, if we wanted to make it a function, we could just draw the line and call it a linear function. Now, if we were to switch the x and the y values, or the input and output values, what in essence happens is there's this reflection across the across this line, y equals to x. And so you can see this line right here, it's a perfect diagonal. If I could draw straight, this would be better, but that is the diagonal, and the equation of that line specifically is y equals to x. And so what happens is, if we reflect it across there, we can see we're 1, 2, 3 units away from that line, so we're going to go 1, 2, 3 units on the other side of that line and create the inverse point. Now, you can create the inverse points in this manner, or you could simply change the x and the y values and create the inverse relationship that way. Now, again, in this particular example, this inverse relationship creates a linear pattern, and if we wanted to put those together, we could draw a line and call it a linear function. Now, you can see that in the inverse relationship, that line is a little flatter, and in the original relationship it was a little steeper. So there is somewhat of an inverse relationship going on there. So if we were to come up with the equations for these, we would then be dealing with a function, and we could show the inverse relationship through the linear function. Now, if we want to find the inverse relationship of anything in particular, what we would necessarily do is, to find the inverse of a relation, we would simply switch the x and the y values and then turn around and solve back for the y value. Now, this is an extremely important concept, not only for inverse functions in this particular section, but in mathematics in general going forward. You will be learning about a number of different functions, and then you will also be learning about their inverse functions, and so you will need to know how to quickly transition between both types. So understand, if you just switch the x's and the y's and then solve back for the y, you can create the inverse function. Now, if we talk about it from a relationship standpoint here in example 1, we have y equals to 2x minus 4. Now, we know that that is a linear function from our earlier lessons. We have a exponent, x is raised to the first power, and that is written in y equals mx plus b form. So we kind of know that we're dealing with a linear function. So if we wanted to find the inverse of this linear function, what we would simply do is take the original function given to us and switch those x and y values, giving us this new equation. Now, the key to this is to solve back for y. So we want to solve back for y now that we've switched the x and the y's. And when we do that, we get y is equal to 1/2 x plus 2. Our original relation, our function in this case, was 2x minus 4. So these two linear functions are inverses of each other. And so if we were to actually draw these two lines, they would actually have a reflection across the y equals x line. And so that y equals x line kind of acts as a mirror, if you will, of these two lines. So that is the most basic way to find the inverse of a function. So it doesn't matter what kind of function you're working with. If you're dealing with linear or quadratic or exponential functions, we're going to be dealing with in the next chapter. So remember, this is probably the most important. I'm going to double start because that is extremely important concept. Switch the x's and y's, solve back for the y. Now don't forget, functions can be also written in function notation. And so if we want to represent the inverse, remember in previous sections with matrices and trig functions that we could represent an inverse with the -1 power. So that would be, these two would be inverses of each other as well if we were putting it in function notation. So that'll come up a little bit later in this section, and we'll talk about that again. So let's take a look at an example, a sample problem that you're going to work. Sample problem number 1 says find the inverse of y equals -3x plus 6. So what I'd like you to do is just go ahead and pause the video at this point, use the previous example and information to find the inverse, and be sure to solve all the way for the new y value. So go ahead and pause that and work on that now. Okay, so the first thing I'm going to do is I'm going to take this x and this y value and I'm going to rewrite them. X equals -3y plus 6. And now I'm going to solve back to get that y by itself. So I'm going to subtract 6 from both sides. I'll then divide both sides by 3. And so I'm left here with y, and then of course I can split this x minus 6 over 3 into two separate denominators, two separate fractions, similar to what we did with complex numbers. So I'm going to say x over -3 minus 6 over -3. And then of course, if I want to rewrite this appropriately, this is an understood 1, so we want to get this in y equals mx plus b form like it was in the original part. So this is going to be a negative, this is going to be a -1/3 x plus 2. And so this linear function is the inverse of the original function. So that is just your most basic way to find the inverse of two functions. So it doesn't matter what type of function that we're working with, we just introduce the concept to you here in linear functions, but we could be dealing with any type of function that we may learn previous to this or after this. We just switch the x and the y's and solve back for the y. So in the next part of this lesson, we'll talk about how composite functions come into play with inverses.